Hello, welcome to El Streamerino. I'm just gonna be kicking back here and making some particular parts of my game again, because I felt like I got some better ways to do things now, and yeah, just kind of felt like it today. I don't know. I haven't deleted the other version of the game, by the way. This is just something I'm messing around with to see if I can, well, see if I like prefer the feel of things this time. Like everything was alright, don't get me wrong, but it's just kind of nice to do a bit of spring cleaning, and especially starting from the base up again. Like if I need something from the main project, then I'll put it back in here, but I kind of want to just see what I can do from scratch right now. Anyway, of course, it's not really from scratch. We still have a bunch of assets. There we go. So, I'm going to start by giving our players some movement. I actually want to kind of build a custom... I want to make a custom state machine again, but I want to try and do it a slightly different way this time and see where that takes us. So yeah. Hey J-Ski. Sorry I haven't got a chance to look at your thing properly yet, but I will be looking at it later. Do you know how to code your game? Yeah, that's more my thing, to be honest, than art. Okay, so we're gonna try and make a state machine. I'm gonna try and explain what I'm doing here so that people aren't like just thinking, what the hell is this guy doing? So let me just open up Paint. So a state machine is similar to the animator in Unity, right? Imagine I have an idle state, and then I have a walk state, and then I have a run state, for example. Now all of these things need to only one of these things can happen at once. So if there's a lot of things in your game where only one thing should happen at a time, there's probably a good chance that you could use a state machine for it, or should use a state machine for it. Sometimes it's overkill, but when you've got a character that does a lot of complicated kind of actions, then you definitely need one. Hey, thanks a lot. So look, we can go from the idle state to the walking state to the idle state, and then we can go to the walking state to the run state, and we can also go to the walk state back to run state back to the walk state. We can also go straight into a run state from idle, and we can also go straight to idle from run, technically. Okay, but there might be situations where we don't want to be able to move between all of these states. Okay, so if my character is picking up something on the floor, so let's just call it a pick up state. Okay, pick up state. So imagine we want our character to pick up something from this floor, and there's some code that's going to be running there. We don't want our character to be able to start running while he's picking something up, because he needs to finish doing that first, right? So instead of that, we make sure that we use a state machine, because in this case, we can make sure that he can only go back to the idle state, you know, once he's finished his picking up state, and we'll keep the logic for that either on the outside of the states or inside, but hopefully more will be made clear. soon. But right now, I'm just going to make the idle state and the run state and the walk state and the state machine, of course. Hey, Franks. And Jayski, I'm doing okay. Much better. So the first thing I'm going to do is make a scripts folder. I always like to have a scripts folder to separate things out, because otherwise it can get a bit messy in like VS Code. So go to my scripts folder. I'm going to create a new folder called states machine. And inside this, I'm going to create a state machine. But first, I'm going to create something called a base state. So this base state, which I'm actually just going to call state, is going to be the foundation for all of the other states that we'll create. Don't worry, the old game stuff is still back there, but we're just not going to use it for now. So public state. I'm not actually going to inherit from mono behavior for this, although you can, and stick it on game objects. But because my game's going to end up pretty complicated, I don't want to have too many scripts attached to my game objects. Okay, so do you think you'll do moving camera? Yeah, there'll definitely be a few of those in there, but I'll probably just use Cinemachine for that, to be honest, because it's like good. Okay, so public class state, and this is something we're going to call an abstract class, because there's not going to be anyone using the actual state as an instance. We're only going to use things that come out of it. I'll explain that in a sec. So what we're going to do is define some methods that are going to be in this state. We could also use an interface like this, especially if we're not going to do anything here. But in this case, I'm going to just use state. Okay, so we're going to say void enter. Okay, so it's going to be a public one. Public abstract. Now, I'm calling it abstract because we don't actually want to call this method from inside this class, because this is an abstract class. So whatever states we have, like walking state, idle state, they'll have to have this enter state. It will also have to have a state enter method. Sorry, it will also have to have a method called tick, which is basically takes the place of update, where it ticks over every frame. And then another abstract method called exit. So the idea is that the player can only be in one state at a time, right? So as we saw here, idle, walk, run, for example. So in the when we switch to a state, for example, if I go from idle to walk, first of all, what will happen is the exit method will get called on the idle state, and then the state will change, and then the enter state will get called on the walk state, and then it will start ticking in the next state. So yeah. So right now all we're doing is declaring some kind of abstract methods that we'll need to override. Another thing you can do is have something called a virtual method, like enter. They'll tell you that this isn't exactly good practice, because it's not good to have empty methods. But then again, if you don't want to use this method in one of your states, you could just have it running empty, and maybe that doesn't make much sense. I don't know. Yeah, I know, dude. Anyway, I'm going to call it abstract. You'll get why I'm doing this in a sec. I'm just going to actually hammer this stuff out and then get to the what it's actually doing later. So we've got a state, and now we're going to create something called a state machine. And this is going to do the logic for the state. It's going to make the states actually do something, basically. So state machine. Now, this this can inherit from mono behavior if we want, which I think I'm going to leave with that. So we're going to have something called initialize state here. Initialize state machine. Okay. And then we're going to say, well, what am I doing? Void initialize state machine. It's going to be public. Yeah, surprise, surprise, isn't it, J-Ski? And inside here, we're going to take something. Actually, we could just call this initialize, to be fair. In here, we're going to take a type of dictionary. I think we might need using system. Actually, systems collections should have it. Dictionary. We're going to take in a dictionary of a type and a state. Okay. And then all states, or available states, I should call that. Okay, so this dictionary is just going to hold a bunch of states that can be used by whatever character is, or whatever, anything. A UI could use this state machine. The character itself could use the state machine, or, well, anything could potentially use it. So it's going to be very generic. The only thing that makes it non-generic is that it has to include some states. It's kind of, it is a type of collection. Yeah, it's a collection. It's in collections.generic, right? But it's awesome because you can assign a value as a key and then the item itself. So you could search, for example, a type. All right, if I want to go and find something in this dictionary, I don't have to go through all of the I don't have to loop through it to find the stuff, right? I just have to search by type. Instead of searching by number, it will still loop through it, but it's searching by this type. So I could have a type of state that I'm looking for, and then I can get that state back from it. And like, it's kind of difficult to explain all the reasons that can be useful, but once you get it, it's like, whoa, that's so cool. Because you could have anything, not just a type. You could have an index number, you could have an integer, you could have a float that references some key, you could have a string that references a key. I do that sometimes. Yeah, it's great. Okay, so initialize. Also up here, we're going to define our dictionary that we're going to set up. So the I'm actually just going to call this states here. So we're going to have another dictionary. This isn't going to be public. This is just going to be private to our dictionary. So it's going to be a dictionary of type and state. Okay. And it's going to be called available states. Because I'm keeping it private for now, I'm going to put an underscore there. That way, it just helps me notice which things are private at a fast glance. Okay, so then in this initialize method, we're just going to say available states equals states. Okay. So once we call that, we're just going to set these states here, dictionary, to this. Okay. So next, we need something to actually work our states. No, it's not about the player. It's more about protecting you from yourself as a programmer. It's especially important in when you're working in bigger teams or when you're not a solo developer, because if you expose variables as private, if you expose things as public, like this public dictionary, I don't actually want to change this thing anywhere outside of this class, okay? I only want this available states to be accessed from inside, because this class is doing all the work on this, okay? So if I made that public, then I could go in any class, get a reference to the state machine and fuck with the available states here, right? And that could cause us side effects in code, and it could cause all sorts of problems because we didn't intend to use it that way. So by keeping it private, what you're saying to other people who might look at the code, or to yourself later, is this is only for this particular class to work with. It's not for anyone else. You get it? I hope I'm clear about that, because I'm trying to improve how I explain things. But if you think about the times when you look back at old code and you're like, oh, what does that do? You know, this helps you realize that this is only to do with this. Okay. And so next we're going to do something that will actually work the state machine. So in our update method, void update, we're going to say, if we forgot to actually have a current state. So next we're going to have a type of state which is called current state, okay? And remember I said there can only be one state at a time. So the way we do this is we only hold one state in this state variable at a time, and then we just switch this variable, and the other state will just replace the state that was there, so that only one state can be active at a time. It's quite cool. Okay, so if current state actually we should probably do that somewhere else. We should probably do that in initialize. So current state equals hang on, using system.link. So you need to define current state as a string or something. Why would I need to define it as a string? I want to know, like, your line of thinking. So current state equals states dot values dot first. Okay, now we're gonna say if, well, we're only gonna initialize this once, but still I want to do this just to be sure. If current state equals null, so if the current state is nothing, I'm asking because I don't know that at all. Oh, okay. So string is a type, right, JSki? And because I've created this class called state, I've created a type of class that I can use anywhere in my program. So this current state is a type of state. That's its type. Like, it could be a string if I wanted. That's just another class that's built in to C#. But I'm making my own custom class called state, and I'm holding a reference to it. Now you're going to see the cool magic with that later. So here we're saying if the current state isn't anything, then the current state, so you access the state class in the state machine. No, we don't access the state class itself. When we do this, we're creating an instance of a state class, okay? Which means we're making a little version of it. Just for context, are you doing character movement or what? Yeah, this is going to be for character idle, walk, and running stuff right now. I'm sorry if it gets confusing, Dutch Viking. I'm gonna try and be as clear as I can, but don't feel bad if you don't get it. Yeah. Okay. So in the update method, we're gonna say current state dot current state dot tick. Okay. Now, this is going to be our way of running some kind of update in our state. Because this is running through our update method here, we're saying current state dot tick. So whatever the current state is, it could be an idle state, a running state, a walking state. We're running the tick method on it, and that's our way of updating that state, because C# classes don't have a way to update every frame on their own. Okay. So, current state dot tick. We're gonna have another method called void switch state, and that's gonna take a type of state. Next state. Sorry, not with an underscore there. This must be a more complicated way of doing it. Yeah. This is a nicer way to do it for building for the future. So what we're doing is we're saying switch state. So what we do now is we say current state. So before we actually switch the state, we're going to say current state dot exit, and we use this exit method to store or to do any kind of resetting to that state, or anything it needs to do to clean up the state, it'll do here. Okay, so current state dot exit, and then it will say current state equals next state. Okay, and then we'll say current state dot enter. So do you get how the state switching is going to work yet, Jayski? Based on this method. So all we need to do is change current state to another state that we give here into the switch state, and it's going to just work. Okay. So kinda. Okay, well maybe when you see it working you'll understand more. Wait, hang on. You're making a clone of the state. See, this state actually doesn't do anything, but I'll show you that in a minute. Okay. So we can also probably just do well, maybe we don't need to inject it there, but we can have it up here. State, next state. So then we can say sorry. I just overloaded my brain. Hang on, I'm going to try it this way first. Current state equals next state. State. Next state. Okay. It's okay, don't worry. It'll come with time. So this is going to be an idle state. Now watch this, okay? So this is going to be a state, an actual state, okay? So this is going to be a public class idle state. And this is going to inherit from state. So the idea is that we watch what happens if I delete these methods here. Nothing? Come on, dude. Well, let let it do its thing here. Yeah, see? Okay, for some reason the auto... Oh, there it goes. So it says idle state does not implement inherited abstract member state.enter, state.exit, state.tick. That means this won't compile unless I add those methods. So now I have these methods here. And do you know why we have these methods here? Why do you think we have these methods here? Why do we have to have those methods there? Does anyone have any clues about that? Yeah. Well, being a teacher probably doesn't help that vibe, right? So, the reason that we have to have these methods here is because we're saying idle state is a state, okay? And in state, we say these are the methods that a state has, okay? So, by calling these abstract, we're actually creating a contract, okay? We're creating a contract with anything that wants to call itself a state. So if anything's going to call itself a state, it has to live up to its contract. And its contract says you need to implement these methods. Okay? So I've done it here so the compiler doesn't complain. Tick is just going to be used to update every frame like update does. It's just another word for update, but we're not using the update word because it will get confusing between this and a mono behaviors update because this isn't a mono behavior. Okay. So, are you following me so far? Okay. So, we create this contract. Now, what would be the point of creating this contract with the state? Hey, Giant Dad. What would be the use of creating this contract that says we have to have these methods on it? What do you think, Jayski? Well, have a look, okay? So in our state machine, we're holding reference to a state called current state. We're holding reference to a state called current state. Now this state might be an idle state. It might be a walking state. It might be a running state, for example. We don't know what we're actually going to store in this. We can store anything that derives from state, anything that calls itself a state, because they are states. Okay? Now, the use of having this now is that I can say, I'm not going to use this in the actual code, but I just want to demonstrate for you. So just on start, for example, I'm gonna say idle state, okay, and then I'm gonna say in start idle state equals new idle state. Okay, so we're gonna create an instance of it, and then I'm gonna say current state equals idle state. Idle state with an underscore. See how I can do that? I can assign idle state into this variable even though the types are different. But because we call this state, we implement this state here, or we inherit from this state, therefore idle state is a state, therefore we can use it like a state. So even though I might not even know that this current state is an idle state, right? All we know is it's a state, but still we can say current state dot enter exit tick. Okay, it could be a running state, it could be a walking state, it doesn't matter. I can always access those methods there. Well, it's similar in the way it works in a very literal way, because it's a state machine, the animation controller. But the trouble with the animator controller is that it can be between two states at the same time, which during the transitions, and that's kind of breaking the idea of real state machines, because a state machine should only be in one state at a time. So anyway, so current state.tick. I'm gonna get rid of this stuff now because this stuff isn't actually needed, because we're gonna pass in a list of different states, like an idle state, and we're gonna pass in a walk-in state to start us off. So now we're going to get rid of that. But what happens if the current state changes? Okay, so, well, first let me create the walking state too. This is going to be walking state. Okay, and walking state is going to also be a kind of state. So we also derive from state. State is our parent, you might say, or our superclass. Okay, and I can have different things working in all of these, but when I call the state.tick, it will be it will work just like that. I can just call current state.tick and it doesn't matter what state it is. I'm trying to really drill that in because it's so powerful. But at the moment we don't know how to change between states. So one thing we could do is we could try something like using a type to get it back, or I should not say things if I'm not going to follow them with something. So we could create conditions on the outside of the states or on the inside of the states, if you know what I mean. We could have one kind of script that checks if we should move between states, or we could do that all inside the states themselves. I actually prefer doing it inside the states, but it's sometimes a bit messy, but it's my preference right now. So instead of having this, it's actually going to be so next state. Hang on, I need the next state here. Type next state. So we just want to get the type of the next state, not an actual concrete version of it. So we're going to say next state equals, and I learned to do this state machine stuff from Jason Unity 3D guy, by the way. So if you're interested in learning it too, I would say that he was pretty good at explaining it, but it still took a few months for it to sink in for me, to be honest. So next state equals current state dot tick. Now that might not look like it makes any sense right now, but what we're going to do is we're going to go here to our state and we're going to make this tick return back a type. Okay, and then we're going to make sure we change this everywhere here. Type. So instead of returning nothing, they're going to return type. Wait, what? Oh, we need to include system here. Love my ghosting here, just leaving empty using statements. So again, using system. Good, good. And then we can say return null, because by default it just returns nothing, so nothing happens. Okay, so what does that actually mean? Well, I'll show you in just a sec. So we say next state equals current state dot tick, a frantic check, and then if next state doesn't equal current state dot get type, then we're gonna say switch switch state, and we're actually going to change this to type as well. Oh no, actually we can probably just store a variable of it. Var next state equals and then we're going to look up in this dictionary. So remember earlier I said you can search dictionaries by a key. Now our key is type for this dictionary, okay? So we're going to search by the type that we've been returned. So we're going to say next state equals dictionary. Oh no, we can send that straight there. Sorry, I'm being stupid. So switch state, and we're going to say available states. And then instead of putting like an integer, like we would usually when we're searching something in an array or a list, we're going to say available states next state. See? So we can search that dictionary and it will return to us a state, and then we can switch that state here. So we've actually got the concretion there. I'm really bad at explaining things. I'm sorry. Okay. We need to make sure current state isn't null. So we're going to do a null check there. And there. And that should be good. So now, in our idle state, this is where some of the magic happens, right? So this theme I'm using, it's called Atmospheric Cyberpunk Synthwave Mix. It's some royalty-free music. It's pretty good. I love this guy's stuff. The guy's name is White Bat Audio. So the magic happens here, okay? So if I want to change state here, so say if I say if key, if input, oh, hang on, using Unity engine. All right, JSKey. Unity engine. If input, oh, this is called Dracula. This is my favorite. If input dot get key, key code dot w, okay. Now, we don't actually want to do anything movement-wise in idle other than turning, but we can make it so it will switch to the next state, okay? So if input.getKey, keycode. Can you dance? Kinda. Input.getKey, keycode.w, then we're going to return type of walking state, which doesn't exist yet, but it will in a second. That's weird. Anyway, rename this to... Wait, we have a walking state. What the heck? Return type of walking state. Oh, I think I need to just refresh it in Unity. Oh, in the game? No, not yet. Okay. Return type of walking state. Turn null. So in the walking state here, we're just going to return null at the bottom so nothing happens. No, you haven't. Stop. Okay, so here we're gonna say, wait, what are you doing? Oh, we didn't even do the system here. So here we're gonna say, well, we need a reference to the transform first, so we should probably pass in a game object. So make sure that when we initialize this, we pass in some kind of a game object. Well, actually, we need to set up the dictionary anyway. So available states equals states, yes. That will be done outside. But in our state, we maybe want to add a constructor. This is the one thing about using non-mono behavior stuff, is you've got to pass in a bunch of stuff, which is kind of annoying. So we can do a constructor called public state. And game object. So we're going to need to include Unity engine here. Game object. Object. Oh, it's because it's obj. Okay, and we're gonna say game object, game object. I'm just gonna do that this way, actually. Yeah. So in here we're gonna say game object equals obj. In idle state, we're gonna make sure that we've added this. Oh no. Constructor to idle, public idle state, and then game object obj, and then base dot obj. Wait, base obj. Okay, and then we're gonna say, well, we don't actually need to say it here, but we could do it. Game object equals obj. That should work. So we're saying we need to pass in a game object to it, and when you're not using C# stuff, you have to do it with the constructor here. But we can just work it in the base class and then leave these kind of empty here. How are you guys doing anyway? I feel like I'm talking to myself, and I'm sorry for that. Okay, so now in our state machine, now we have a reference to this object called game object that we want to have. So now in tick we say, well, let's store the transform somewhere. So let's just call it transform. Oh, actually, we could do it in the constructor. Sorry. Public. No. Transform. Transform. I'm going to move this constructor. God damn it. Actually, maybe it's better under there. What do you think the major distinction between C# and any other? Well, there's not much difference between C# and Java. To be fair, C#'s like a competitor to Java. I don't know about other programming language. It's like it's more strongly typed than some other languages. So you have to be very explicit about what you say in a lot of cases. My brain isn't working today. So anyway, transform equals obj.transform. Okay, and then in our idle, we're gonna also pass in this transform here. So transform then we're going to say transform equals obj.transform. Now, what are you complaining about, Unity? You didn't see nothing. Okay, so state game object. Now that we have a reference to our transform, in our tick method we can say transform dot what we can do for now, I'm just going to do transform position. Oops. Transform dot position equals transform dot position plus transform dot forward. Oh, it's doing that. I'm used to writing times 10 times time dot delta time, but I'm gonna change that to use the physics engine better later. Time dot delta time. Oh, what am I doing? Okay, so I'm just gonna test this, but first we actually need to set up this state machine somehow. To do that, we need to initialize. So I'm gonna start a state controller, I guess I'll call it for now. State controller, and this is gonna be a mono behavior too. State controller, and we're gonna remove all this stuff, don't need it, and we're gonna say dictionary of type and state. Okay, available states. Okay, and then in our start or awake method, probably would be better, we're gonna say available states equals new dictionary type state. Then we're going to open this up and we're going to open a bracket here. Hang on. I'm going to say the type is type of idle state. Well, I mean, everything's kind of a procedure, right? I'll try and I think once I actually demo it and show you what it does, it will be easier to understand. New idle state, and then we need to pass in the game objects. Okay, and then we're gonna make a new one, type of walking state, new walking state. Game object pass in as well. That's a funny looking blender, yeah. How's it going, sheep? And we make sure we add a little comma here. Okay, so when we awake, we're setting up this dictionary. we also need to hold reference to this state machine. So we're going to hold a reference here called state machine. Hey. State machine. Where the fuck? Hey. You're public, aren't you? That's weird. Hang on, let me refresh in Unity. It's probably just being lame again. So, go to our... oh, I didn't rename it, that's why. Oh, I saved it and it's something else now. That's not good. Wait, state controller, state machine. I renamed them the wrong things. So let me call this like... Yeah. For a sec. State machine. And then we'll call this state controller. State controller. Okay. So in the state controller, now we hold reference to a state machine. And that's going to be called state machine. And in the awake method, we're also going to get that. So state machine equals get component. Get component state machine. So we'll get the state component attached to the game object. And then we're going to set up our available states. And we could actually put this into a thing of its own. So let's call this, let's extract a method. And we'll call this method start state or initialize state machine. Bit long, I know, but at least it's descriptive. I don't like things being saying private, even though they are private. So we're going to set these available states here to a new dictionary containing these values. And then we're going to say state machine dot initialize. And then we're going to pass in our available states. So that's what that asks for. And then, so this is the first thing that happens. We pass this dictionary into the state machine. And then the state machine is going to set its own dictionary to the available states. And then it's going to set the first state to the first state, which is the idle state in the dictionary. And then it's going to update the states. And if my calculations are correct, this should work in a pretty primitive way already. Just to demonstrate, I'm going to just log here if we got into the idle state. Inside, wait, enter idle state. Okay, so let's have a little looky. We need to add a state machine to the player. We need to add a state controller to the player, but we don't need to add the states because they're all handled separately. And I should probably rename this to player state controller because this is going to be specifically about the player, but for now I'll leave it. So which thing did we not do yet? Okay, if next state doesn't equal current state dot get type. All right, let's just do a null check up here. If current state doesn't equal null. Right. It feels like the dictionary isn't getting there yet. So how is the dictionary getting there? Let's make sure that in the awake method, we'll check what the available states is. Debug.log available states, and then with the index of type of oh wait, no, type of idle state. I'm just going to check that that dictionary is actually doing anything yet. Yeah, so it's got the idle state. So now let's debug a little further in. This is the thing that's causing us issues. Now, right now, next state is null. Aha. So if next state doesn't equal null, and next state doesn't equals null. Okay. Yeah, there we go. Okay, so we're in our idle state now. Now what I'm going to do is I'm going to set it so that every time we switch states, it's going to log to us that we're in that state. So we've got one for when we enter into the idle state. Now we get one when we go into the walking state, okay? Now, this is where the magic is happening. So now you should be able to see how powerful this kind of system can be, okay? So here we're going to say if input dot get key. So if there isn't this key pressed down, keycode dot w, then we're going to go straight back to our idle state. So we're going to return a type of idle state. Okay. Now, watch. Are you ready for this donkey to lay eggs? Because the donkey is about to lay eggs. So, idle state. That's the state we're in now. Walking state. Enter idle state. Enter walking state. Enter idle state. Okay? So he's switching between these states because he can only move when he's actually in the walking state. So this is incredibly cool. To demonstrate this further, I'm going to add some input stuff here. So if input.getKey keycode.a, we're going to say transform.rotate. Transform.rotate, and then we're going to say 0, 0, 1, 0, minus 1, 0, and that should be all right. Yeah, once I'm finished, I want to try and go through it all to be clear with it. And I'll try and talk about it in a really high level way so it's easier to understand. Okay, so now what I've done is I've added some way that the character can turn for our tank controls, but only in the idle state right now. So he can turn in the idle state, and he can only move forward in the walking state. So let's watch what happens now. Now, there's many states where the character wants to be able to turn. So we don't want to actually... I'm going to slow him down a sec. We don't want to actually... we don't want to have the character turn in a separate state. We don't want to have like a turning state, because he needs to be able to turn and he needs to be able to walk at the same time. So that's why I've left it not in its state, but something you can do in many states. If you wanted to really like blow your mind up, you could make smaller states within states then. Like I was saying to someone the other day, in like Dark Souls, for example, big bosses will have states, for example, for each limb of certain bosses, state machines for each limb. So think about that one. So I have no way of proving this to you, but you should be able to see by how he's moving that it's kind of impossible for him to turn and walk at the same time. Okay? So that's part of the power. We don't actually want to use that here, but imagine the power that that gives you. Okay? You can make sure that the character can only display certain behavior in certain cases. I'm also going to add... Yeah. I'm also going to add a... I'm going to add this into our walking state so that we can also turn there. Now, one of the things with programming is if you start to see a lot of repetition within your code, in your scripts, that's probably a case where you can start abstracting things out or finding ways to combine that all into one place. So one thing we could do is we could create something called player movement. Okay, and that will be a separate class. And then instead of doing all of this checking here, we could just call a class on player movement that does all this check. So we can say, we could just say process turning and process forward movement. Hey, Appley. So now we should be able to turn and walk at the same time. Okay, so now we can turn and walk all at the same time, all with magic. Maybe I'll just hook up some animations quickly right now so that we can actually do more than just slide along the floor. So let's create a place to store the Animator Controller. How you doing, Appley? So in here, we're going to create a new Animator Controller. We're going to call this player. And then we could create a new state, which will be called idle state. Yeah, use the sexy turnaround animation we made, exactly. Yeah, so we're going to call this idle. And then we're going to call this walking or walk, whichever you prefer. So this will be... I'm actually going to call this walk state, because sometimes you have to search up things by string here, and it's better if they're small. But there are arrays around that, but I'm not going to talk about that now. So the motion will be our player.idle, wherever it is. And then walk will be player.walk. I'm not sure if these animations are actually hooked up properly to this model, but let me just check. Animator, runtime controller, player, avatar, none. So we need to create an avatar for our player. So let's select the import here and go to our rig and generate one of humanoid type, create from this model. Can leave that like that if we want, I guess. It has import warnings, but it always tells me that. I just ignore it. So the avatar will be player avatar. Hopefully this will do something now. Yeah, so we got his idle animation there. Add a transition to the walk, add a transition back to the idle. And this transition is going to be called is walking. If you use booleans, I always like to say is, because then you know that it's a boolean. It's something that can be true or false. Is walking, or has, or should, or could, or can fire, for example. That's one I use. Is we don't need to do anything for an idle thing, actually. but we can have the condition going towards walking to be, is walking true? So if we're walking, then we want to go play the walking animation. And if we're not walking anymore, we want to go back to our idle animation. And now you can see how the animator is very similar to the state machine, right? Because you can only be in one state and it has conditions that transition between them. So this should be working if I just add something here. So on our enter walking state, we're going to set, welcome back. We're going to say, well, we need an animator. So what we can do is we can get the component off of our transform here. So we can say transform.getComponent, animator. No, not yet. But I can point you in the direction of some. But don't feel bad about it, Jayski. You will get it. It's not actually as tough as it seems. So we're going to hold reference to an animator now, and that's going to be called animator. And then we're going to say here, animator equals get component animator. So we have to get things off of this transform. And this is only called once, so don't be afraid of using this get component in places where it's only called once in the code, not every frame. So now in our enter, and this is only triggered as soon as we enter our state, okay, we're going to say animator.setBool, what did we call it, is walking, and the bool value is true. So that's the only place we're going to handle that. And then in our exit, we're going to set it back to false, is walking false. So now it should be working. But it's not. Oh, we're triggering the Boolean. Did I set player.walk, player.idle? Let's have a look at that animation just to check that it's okay. Yeah, looks good. He's definitely rigged up okay because he's playing his idle animation, but for some reason, did I set this animator to the player? I did. Okay, that's weird. Let me check that this condition is here. Is walking true? Yeah. Oh, we've got a long exit time. That's what it is. So if I set this to like very short now and find the... Okay, there we go. Yeah, so now he'll walk, but obviously we need to make it all loop, and we need to remove the exit time here and make him kind of step down a bit slower maybe. So yeah, thanks Jayski. Okay, now we're gonna go to our animations and make sure we loop them properly. So we go to our player.idle, make sure that has a loop time, and then we go to our player.walk and make sure that has loop time enabled too. And now all of the walking should be set up. Okay. Well, he's stopping a bit slow, but that's okay. I think he starts okay. Okay, now let's just reduce that transition time a bit. That's better. Wee! What are you playing at? What are you playing at, dude? Did I not save the I didn't apply it, did I? There we go. Okay, there we go. And now, yeah, we're going between these two animation states, but we're also going between our two idle state and walking state. And remember, only one of them is ever active at a time. And having these enter and exit methods is really good for setting things up that only need to be triggered on entering the state or on exiting the state, obviously. So it's really, really cool. Hey, Nicholas. So how about we think about a scenario where we might want a different state. So let's say that the player might want to pick up something on the floor. Okay, so we have a pickup animation. This is a really good case where we'd want to use our states. So I'm gonna create a new state now, which is gonna be called pick up states. Pick up state, or maybe interact state, but that's a bit vague. Maybe just examine state. And all we're gonna do right now is he's just gonna bend down and look at something on the floor. Okay, so examine state, which is a type of state. So examine state. Now what things do we need for the examine state? We're gonna need that's just one of my apparent fans. Don't worry about those 2 dislikes. He always comes in, dislikes my video, and then later removes the dislikes. And I don't know why he does it. Okay, so we're probably going to need the animator. We need the transform as well, so we can get the component of the animator, so we can keep those. And on entering this state, we're going to set a bool called is examining on exit. Okay, and we could just do it by the timing of the animation probably, but I don't want to mess around too much with that, so I'm just going to set a timer. So when we're actually examining, we don't want to do anything. So I'm going to basically find a way to soft lock our character. If you see in a game you get into some soft lock situation, the majority of time there's a state machine involved. So think about how many games you've had soft lock. There's a good chance that a state machine is involved somewhere there, because it's all about getting locked in a particular part of the logic that you can't escape from, because you can never meet the conditions to escape. Thanks, Dutch. Okay, so now we need to go back to our state controller and add a new type of examining state. Examining state. Oh, examine, sorry. Examine state. It'll work in a sec. New examine state. Game object. So, the magic of refreshing Unity. Ooh. What happened there? That's not a method, silly. Oh, sorry. This is supposed to say examining state. Examine state. So, now, watch the magic unfold, okay? Now we just need to find something to actually trigger him into this. So, what we could do is, I like to do things the old school way, and we can create something called a examine controller. I'm probably going to rename this later, but it's just something I'm going to use for now. So the examine controller is going to check if we walk over something, like some item, for example. We're going to God, what am I talking about? My brain isn't working properly. So we're going to we're going to create an event here. We're going to call it something like public static action. Oh, I need to be in the system namespace for that. Yeah, it's not working. Public static action item. I'm gonna need to make an item class as well, but I can do that in a second. I'll just call it an action right now. Item on item examined. So we're gonna create a public static action called on item examined, and if the player bumps into something on the right layer, for now, later on I probably use something else for it, but it, what do we say? On collision enter, or on trigger enter, I should say, probably. So on trigger enter, collider other, if either dot get component item fuck off. I haven't set up the item yet. This is the problem. I'm just going to do that quickly. Copy paste. Rename this to item. Okay, and then in the item, it's just going to be public class item derived from mono behavior, and then it's going to be blank for now because we don't actually need it to do anything yet. We just need to check if something is an item by if it has this script on it. There's better ways to do that, by the way, but I'm just doing it fast. So if other dot get component item equals true. Slow to call this through every collision, by the way. Let me just refresh Unity. So if other dot get component item equals true. So if it has this component called item attached to it, then what we're gonna do is on item examined dot invoke. Do you think you could have a carbohydrate or cardboard box? Oh, totally. So on item examine dot invoke. So we're gonna send this event if our character bumps into any item, and also wait. Oh, I just thought maybe that's not the best way to do it. I've just had a little musing. Maybe Bubbles will help me think. What do you think, Bubbles? Again with the silent treatment, huh? Ah, no, we could do that. So what we're going to do is we're going to go to our... We could go to our state, in fact, and have something called item, and we're gonna make this we're gonna make this a protected because we want the Bubbles is in trade. Oh, yeah. Well, I'm thinking about redoing like a lot of the game, to be honest, because it's just I've got all these different ideas of things I want to do, and it seems like could be just fun. Just thinking my way around this, the best way to do it. It became too sentient, yeah. No, I can. They've been built in a way that I can plug things in, you know. but it's more about things that are about the core gameplay, because I haven't really built that much out of that yet. Okay, so in our examine controller, we're going to store reference to something. Instead of using this event, we're going to store reference to a public item, and we're going to call it examined item, right? And now on trigger enter, if this component has an item, then we're going to set item examined item equals well, I'm gonna cache this first, right? Var item equals other.get component. Then we can get rid of the conditional, and we can say, right? No, we can say if either. So you decide your character's going to turn around with a specific or use rate. I don't know yet. Yeah, it's a bit more. So, examined item equals item. And then, no, wait. If item doesn't equal null, then examined item equals item. So if it's nothing, then if it's not nothing, we're going to set it to that. Okay, now we can get a reference to this examine controller in our idle state. Okay, and we're going to say examine state. And to get that, we're going to use this transform dot get component examine state. And once again, we only call in this once, so don't worry. Examine state in examine controller. Sorry, what the not examine state. Examine controller. Examine controller. So you can access other scripts outside that you need access to within the state machine. Just make sure that the behavior to switch in states and the transitions between them is inside or somewhere dedicated. So what I'm going to do now is I'm going to say if input dot get key down. It doesn't really matter if it's get key or get key down, really, but we can use get key code dot, let's say space. So if input dot get key down, key code dot space, then if examine controller dot examined item it doesn't equal null, then we're going to return, we're going to switch states to the examine item state. Examine state. Okay, so it checks whether the character's actually examining something, and then it's going to switch to the examine state. Okay, and then when we're into the examine state, I'm gonna say where is it? Yeah, start is examining, and we also do a little ball here so we can a little log, sorry, so we can see that we're entering the examine state. We see how it works. So I'm gonna go, oh, hello Bubbles. So now I'm gonna create a animation here called examine, and I'm gonna create a new bool called is examining, and then we can only go there from idle right now. You might be able to do it from walk or run if you want to, but for now it's just going to go from examining. So is examining true, and then to make a transition back is examining false. Okay, and now we're going to set this motion to pick up low, I think it's called. What is it called? Pick up low. So now he's just going to bend down to pick something up if we press space and if there's an item between us and he's in the right state to do so. So let's create an item that he could interact with. So let's just create a cube for now. Okay. We're going to make this small. We're going to add a box collider. Oh, it's got one already. That's good, isn't it? But we're going to set the thing here to is trigger because we're checking on the trigger enter. Let's give it some material because we're feeling fancy. Let's give it the nice wooden... No, actually, that doesn't work, does it? So, we're going to add the component here of item. By the way, you could just use a tag to do this, but the reason I'm using an item script is because this could hold a bunch of data about the item that we can then send to the examine state for use by the UI later or whatever. But for now, all I need to do is put an item state, item script on it, and it should work unless I've forgotten about something. So if I press space, state machine, let's see. We need to make sure we include this in the examine control. No, we don't. What am I talking about? There's always something, isn't it? So if examined controller. Oh, we don't actually have the examine controller. That's because... Wait, what? We got the examine controller. Oh, no. Only in this? Yeah. Let's just do a log here. Check that we've got something. Check that we're getting past this point. Alright, see you later, Giant Dad. Thanks for stopping by, as always. Okay, so let's try that again and just see where we get to. Yeah, we don't even get to that point. So, what it means is that either the examined item is... No. It can't have the examine controller. It can't have a reference to it somehow. If... Let me just log the examine controller here to see if it actually exists. Log. Oh, I'm an idiot. I didn't set it. So I need to say examine controller equals. Yeah, that would probably help, right? Okay. Now it should work. So now we're in the examine state. Oh, we need to fix his animation. Doesn't have an exit time. We need to apply root motion. This is happening because we're doing something weird, I believe. So let's just select this and select can't remember where you put it. Yeah, in animation. Apply root motion, root transform. That should fix that now. Where is it? Pick up low. Yeah, okay. So now let's have a look. And everything should be all gravy, I believe, he says. So, where's our box? Oh, it's over here. So, oh, sorry, that was the wrong animation to use. Not pick up low. It should be crouch. Crouch. There we go. So let's have a look. So, well, I don't know why that's looping. That definitely shouldn't loop, but the logic is working. So let's just have a little fix. So, crouch, no loop time. So the stopping animation is transition between walking and idle state. It doesn't need an exit time. If you turn loop time off, then it should just stop. Dude is dancing, yeah. What do you mean the stopping animation? It's something to do with the animator controls here. I'm pretty sure. Fixed duration, no. Interruption source, next state. It's not to do with it, but just laying some dinosaur eggs over here. He's getting funky. Okay, so has exit time? No. He's examining. Oh, this is false. This should be false. Yeah, you could use the same technique. And this is really the power of the state machine, okay? Because now I'm locked into this state, okay? So imagine you can't see, but I'm mashing my keyboard here. Imagine, yeah, that your character wants to pick up an item. Now, if I could, I mean, the animation when you release a moving key. Oh, you mean in the animator? Yeah, these transitions just smoothly transition between these two things. See? And you can move the point where it starts by moving this. Like, you can blend the animations together in a different way. I want all kinds of nonsense features from the game just because, like, sitting down, peeing... Yeah, that'd be cool. So, yeah, getting back to what I was saying a little bit. Just to demonstrate this, imagine... We're going to pretend for a second that I don't have a state machine, okay? And... what I'm going to do is in the examine controller, examine state, sorry, I'm going to make it so he can move, okay? And I'm going to make it so all of this stuff can move. Wait. If input dot get key code dot w, will the UI be locked to? Only the thing that is working within the state machine. You can have a separate state machine for the UI. You can have a separate state machine for the game in general, like the game flow. You can have a separate state machine within other state machines. It's so cool and so flexible, and it really helps you make sure that your games are more sensibly stable. You know, you're not gonna break things all the time, because you know that whatever behavior you add to a state, it only concerns that state. It's not going to affect other states. So now I've set it to pretend like we're not having a state machine, okay? Just to give you guys an example of what can happen. So imagine, okay, I bend down to pick an item. Now, because I don't have a state machine, I can just do this, okay? And that's not a good look, is it? Why can I do this? Because I'm defining all of the behavior in one place, and I'm not, I didn't add any if statements. Now, imagine if you didn't have any if statements here. Sorry, imagine if you didn't have a state machine, right? And you had all of this logic in the same thing, then you'd have to constantly say if player dot can move, if player isn't examining, if player is walking, if player, blah, 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 then I'll let you do this. Otherwise, no. And then you end up with this. If this, else, I'm making it messy on purpose. Else, this, okay? And then else, and then we say if if you're making a big game, it will end up like this, like guaranteed. If you put all of your logic for the character movement and everything in one place, and you know, it's like you're gonna end up with all of these if statements, and you're gonna be labeled a scrub forever. So let's take all of this junk out of here. So now the beautiful thing. Yeah, don't worry about it, dude. Everyone starts out like that. I'm only kidding when I say that. So we're gonna have a string here, okay? And it's gonna be called description. String description, okay? And then I'm gonna use a method to get that string. I could make it public, but I don't like doing that. So we're gonna make a public method instead called public string get description. Get description. Okay. So get description. Return description. And then we're going to make this a serialized field, so we can actually add a description to the item in the inspector. So serialized field. I can't spell, obviously. Serialized field, sorry. Now watch this. This is all about reusability of code. So we have a box now, right? But it's just an item. This is a white box. Fuck it. It's stupid. And I hate it. Okay, so now what we're going to do is in our examine state, because we have reference to this item in the examine controller, in our examine state, we can actually do this. We can say, well, let's pass a reference into our examine controller. Examine controller. And then we're going to say examine controller equals transform.get component examine controller. Okay. And then within here, we're going to say when we enter the state, instead of logging this, well, we can log when we enter the state anyway, but what we're going to do is we're going to say if, well, we actually know that the thing that we're examining is already valid, but it wouldn't hurt to do a null check here. But we're going to say examine controller dot examined item debug.log, sorry, debug.log examined controller dot examined item dot get description. Bit of a mouthful. We could break this up if we wanted. We could just we could make a string here called string examined text, and then we could say examined text equals examine controller dot examined item dot get description, and then we can just log that. Log examined text. Anyway, watch this. So now it's keeping within the rules of keeping all the behavior inside the state and everything like that. But now we can get the description of this item. See? What does it say? This is a white box. Fuck it. It's stupid. I hate it. Now, watch what happens if I make another one of these. But this time, I'm going to make it blue. So props, create. Or I can make it like this. And this is going to say, this is a box with some shitty ass texture on it. Okay? Now, this is where the magic of reusability is. Okay? So, let's walk over here. This is a box with some shitty ass texture. And if I was to go to the other one, this is a white box. Fuck it, it's stupid. I hate it. See? And we just give it, all we need to do is make sure in our examine state, we hold a reference to this, examine controller. And the way we get that is just through the transform. So usually what you want to do is inject the transform into your states somehow. We do it here. We inject in the transform when we actually set up the states in the state controller. We inject the game object, but this could just as easily be transform. That's how we get the transform in there, through that game object. So yeah, it's pretty cool way of doing things. Now, this item, it doesn't have anything, you know, but we could also have another method on here called public void destroy item. Okay, and then we just say game object destroy game object, and then what we could do is go back to our examine state and say examine controller dot examine item dot destroy item. So even though we are in our state, inside our state behavior, we can still interact with objects around us in the world. See? Which is really nice. Anyway. So we might use that if we're picking up items and things like that, for example. But yeah, I'm going to just take away this destroy item because it's not actually going to be used right now. But anyway, I should finish the stream, guys. I hope someone learned something from this, because it's hopefully useful for you. I don't know if it will be though. My brain's kind of in a really weird place today, and I'm not fully aware, I think. So yeah, I hope it was useful somehow. Yeah, anyway, I'll see you guys later. And if you're watching and you haven't subbed and stuff, then yeah, don't be put off, and don't be put off, J-Ski. Like, honestly, you'll get there. It's not that tough once you go through it a few times. Maybe I'd create a video about state machines at some point and try and get it across in a simple way, but I find complicated topics like that quite difficult to talk about. Okay, anyway, I'll see you guys later, and I'll see you on the next one. Nice, nice, Viking. It's good to see you excited about your game. See ya. Bye, everyone. And bye, Tingle. I don't know if I said hi to you. I just realized I wasn't sure if I acknowledged you, but hi. Bye, everyone.